ratio in terms of a letter is when they give us either the sine, the cos, the tan of a particular angle, normally 99% of the time an acute angle, and they tell us that it is equal to a letter, and then they ask us to find ratios in terms of that letter. When we are in grade 12, we have to be aware of the fact that we can use our compound angle formulae and our double angle formulae. So I've got those pasted in the top left-hand corner for us as well, because we may need to refer to them. Okay, so let's have a look at a typical example of the sort of question that they could give us in this section. So the first thing they say is, if the cos of 25 is equal to k, determine the following in terms of k. So they want expressions for those ratios in terms of k. Now, whether these questions tell you to or not, you are, number one, not supposed to use a calculator. That's why you can see at the top there it says no calculators. And the other thing is that you are supposed to draw a diagram. Okay. They cannot penalize you for writing too much. But you can be penalized for writing too little. So for the sake of drawing a diagram that's going to take you all of 2 seconds, it's better for you just to have that there. Sometimes there are marks awarded for it and sometimes there aren't. So who knows what they decide to do at the end of the year, whether they decide to be more lenient, things change from year to year, what they decide to do, but it's better for you to just have the diagram, okay, as well as how you worked out what you need to before you could answer the rest of the questions. Okay, so if the cos of 25 equals k, how do we interpret the meaning of k? What does that mean for us? What does k represent? Any ideas? What does k represent for us? What does it mean? So the cos of any angle, if I say to you, I have cos theta, the cos of any angle is what over what, Matrix? Okay, try not to think in terms of hypotenuse and adjacent. Try to think in terms of x and y's and r's. The cos of any angle is? That's it. There we go. Well done, Capano. Well done, Lebogang. Perfect. Is x over r, our basic trig ratio for cos theta. Okay, lovely. Well done. So if we have been given k is k over 1. All right, so what that means for us is we interpret x as being equal to k and r as being equal to 1 for this particular question. If we draw a diagram, our angle is acute, so our terminal arm will come to rest in the first quadrant. There's our angle of 25 degrees. There's our right angle triangle. Okay, and we should label that it's 25 degrees. At the end over here, we have x, which is k in this case, and y, and the length of the terminal arm is 1. We now need to use what to work out what y is in terms of k. How do we solve for y in terms of k? What do we use? That's it, Pythagoras, 100%. Okay, so we say that k squared plus y squared equals 1 squared because of Pythagoras. That means that y squared is equal to 1 minus k squared. So y will be equal to root 1 minus k squared. And I'm not worried about the sign of y because I'm working in the first quadrant where y is going to be positive. Okay, so now that we've done that, got the diagram, got Pythagoras, we know what y is in terms of k. Now we can start answering the questions. When I do these things, always like to make myself a little summary. So over here, I'm just going to put x is equal to k, and I'm going to put r is equal to 1. And now I know what x and y and r are. I can answer any of the questions that follow. Okay, because remember, whilst cos theta is x over r, if you answer any question on sine theta, that would be y over r. If you answer any questions on tan theta, that would be y over x. Okay, so let's have a look at the first one, number 1. They give us the cos of 155 degrees. Okay, so we need to somehow try and get that down to 25. So we could use reduction formulae, 180 plus, 180 minus, 360 minus. What will work in this case? What works in this case? Exactly, 180 minus. Lovely, well done. Okay, so we are going to write the cos of 155 as the cos of 180 minus 25. All right, and now we need to be careful. All right, we're going to apply our reduction formula. Palesa, I'll ask Yolanda to help you. I don't know why you can't see the screen. Yolanda, just help Palesa, please. Exactly, and Hlantla, it
Yes, I'm on
reduces
it.
to, thank you, negative cos 25. Now, this bit that I'm highlighting in blue, you do not need to show that. You're not going to get any marks for it. But this bit in pink over here, this minus cos 25, you must show this. Okay, you must show this. Okay, that's where your first mark is actually going to be in this case. All right, so if you are applying a reduction formula, you have to write what you get as a result of your reduction. Okay, so if the cos of 25 was k, then negative cos 25 would end up being negative k. All right, so something like this would be out of 2 marks. 1 mark for the minus cos 25, 1 mark for the negative k. We actually don't need the diagram just yet, but maybe we will shortly. Okay, let's do question 2. In an ideal world, I should write underneath, but I'm going to write next to it because that just makes it easier for us online. All right, so now we have got the cos of 50. Okay, so what do you guys think we should do in this case? What do you notice about 50 and the angle that we've got? This is a double angle, absolutely. So Nhlanhla's right, Nolwazi's right. Lovely. It is a double angle. So can I just double the ratio then? If it's double the angle, can I just double the ratio? So if cos 25 equals k, can I say that the cos of 50 is 2k? Is it that easy? Yes or no, Matrix? What do you think? You're all saying yes. You're supposed to be saying no. No, 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 no. If I double the angle, I cannot just double the ratio. Why not? Why not? Why doesn't it work like that? I'm so glad Nhlanhla and Anwaba said no. The rest of you that are saying yes, why are you saying yes? Okay, because we're not really thinking if we just do that. That's the problem. Okay, so let's just talk a little bit about why, although I'm sure I've had this, because it does not equal the same thing. Absolutely it doesn't. Okay, so let's just have a little conversation here on the side about why it does not equal the same thing. Okay, so I digress a little bit, but I think this is important since so many of you actually answered yes to that question. Nhlanhla, I know you said no. If you want to do sine 25 and sine 50 in the meantime, you're welcome, or you can listen to the explanation. I just don't want to hold you up. Okay, so think about your sine curve. Okay, so I'm going to draw a sine curve, a cos curve. Yeah. Okay, there's a cos curve. Not drawn very well by me, I must be honest, but it doesn't matter. Okay. Let's think about special angles, because this is something that we know something about. Okay. Here's 0 degrees. Here's 30 degrees. There's 60 degrees. Okay. If I talk about the cos of 30, what does that give me? The cos of 30. It's a special angle. What is the cos of 30 equal to? You know your special angles matrix? There we go. Root 3 over 2. Right? So now, if I double the angle, okay, so I've doubled 30 to get 60. What is the cos of 60? A half, exactly. All right. So now look at what we've written here. The cos of 30 is root 3 over 2. The cos of 60 is a half. When I double the angle, do I double the ratio? I've doubled the angle. Has the ratio doubled? No. Okay, so I haven't got root 3 over 2 times 2. Okay. No. So when I double the angle, I do not double the ratio. It's the same idea here. Just because the angle doubled doesn't mean I'm going to double the ratio. It doesn't work like that. And the reason it doesn't work like that is because you are working along a curve. Okay, remember your cos graph is a curve. Right, that's why it does not work. Okay, so if you double the angle, you are not necessarily doubling the ratio. Okay, so that is not going to work. And it's the same thing. If you halve the angle, you can see if I go from 60 to 30, do I halve the ratio? No. Okay, so that does not work. If I see the cos of 50, it is a double angle. I have to use my double angle formulae. All right, so because I'm working in terms of a letter, it doesn't matter which one of these guys I use. Let's say I'm going to go with 2 cos squared 25 minus 1. Is everybody happy with that? I could, if I wanted to, write cos squared 25 minus sine squared 25. I could also write 1 minus 2 sine squared 25, but because I'm working with a cos of 25, I'm going to go with the one in the middle, which means I don't have to do any other calculations other than substitute. Okay, so the cos of 25 is k, so this will become 2k squared minus 1. Does that make sense to everyone? Thumbs up, thumbs down, how are you feeling? Okay, Gugu, Linda. There we go. Londani. Okay. Ntukozo, you have a thumbs down. What's wrong, Ntukozo?
We are here to help, guys.
Absolutely. Ntukozo, if you want to go for it, Ntukozo.
Hi, ma'am.
Hi, Ntukozo.
So, ma'am, when we're using double angles, we're not supposed to square the ratio. Can you please explain that again?
Okay, so I'm using what I've done here is I'm saying that the cos of 50 is the cos of 2 times 25. So 50 is a double angle. And then I'm using this expansion over here, 2 cos squared a minus 1. So I'm writing it as 2 cos squared 25 minus 1. So cos squared 25, the cos of 25 is k. So cos squared 25 is k squared. So I'm substituting the cos 25 for the k. That's why I have 2k squared minus 1 as my final answer. Does that make more sense than Ntukozo? Okay. All right. So k is your output in this regard. K is your ratio. All right. So if we go back over and we look at our diagram, over here, x is equal to 30. X goes in, and there's our output, root 3 over 2. Okay, when 60 goes in, a half comes out. So instead of having these numbers over here, we've now got k as our output. Okay, k is our ratio. That would be our y value on our graph, essentially. Now we have got the sine of 25. So we're working in terms of the same angle now. This is our diagram over here. The sine of 25 is y over r. Okay, so sine 25 is going to be equal to what in this case, Matrix?
Ma'am?
Yes, Linda?
Ma'am, it's going to be root 1 minus k squared over 1.
Lovely. That is excellent. Well done. Over 1. Perfect. Okay, and if you write over 1 or if you leave that over 1 out, it doesn't matter because we've got the 1 in the denominator. Perfect, Linda. Thank you so much. Okay, now number 4, the sine of 50. Okay, so what should we do here? I would like one of you to unmute and tell me, please. What should we do with the sine of 50?
Ma'am?
Yes, Linda.
Ma'am, we could use the double angles of sine 2 theta.
That's it,
Which would be
lovely.
equal, yeah.
So what would it be equal to?
Ma'am, it would be 2 sine 25 cos 25.
Oh, beautiful. Well done. Very nice. Okay, excellent. Good stuff. So that would give us 2. The sine of 25 we've already worked out is root 1 minus k squared. We know that the cos of 25 is k. So I'm going to put the k there, and then I'm going to put the root 1 minus k squared over there. Okay, any questions? Okay, so Linda's happy, no questions. I've put green ticks where the marks would be. Okay, so the only one that's out of a little bit more would be number 3, because we need the diagram and Pythagoras. Okay, the others would be out of 2. Remember, you've got to write what you get when you apply a reduction formula, or if you use a double angle or a compound angle. Okay, you have to show those, you get marks for them. Okay, so then if there are no questions, I am going to challenge you guys to do this. I'm going to make this a little bit bigger for you. Go a little bit bigger. There we go. That's that. Okay. So you guys are going to do question B. I'd like you to try and do all the way from number 1 to number 4 on your own. Okay. If you get stuck or you're not sure what to do, please don't just sit there and feel lost and confused. That's why Yolanda and I are here to help you. When you've done up to number 4, then you can say done. Okay, but I will just keep checking in with you to see how it's going. Okay, off we go, matrix.
Hi, Palesa, with a beautiful smile. So you better get a pen and a paper so we can do activities, girl. I see you working out there, walking, and I'm not sure whether you are holding your pen and your paper, so I'm picking up on you. Run, run and get a pen and a paper so you can sit down and do activities with us. I'm just jealous. Remember to say done when you're done. I know this can take a little bit longer since we're not using calculators. But you see, Mamelo is like, I'm done. Well done.
Okay,
Mamelo.
Mamelo, that's good. Okay, so Mamelo. Copano. Lorraine, no problem, Lorraine. Tara's done. Okay. Nabasutu's done. Good. Okay. So what I'm going to do is this. It's not exactly ratio in terms of a letter, but it's something to think about. Okay. So those of us that are going done, 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 I want you to look at the question that I've put into the bottom left-hand corner, question number 5. Okay. And I'm going to slowly work through the answers from number 1 to 4. We can mark it, and then you can tell me what you think about question number 5. If this pitched up in a test or an exam, how would you answer it? Could you answer it? What would you do? Okay, so number 5 is something for you to think about. All right, I'm going to do the answers for the question on screen. We can mark that. In the meantime, if you're done, look at question 5 and think about how you would answer that. Okay, so in number 1, I got the cos of 18 to be root 1 minus t squared. Do the rest of you agree with that? Yes, and Tlantla, you got the same thing. Okay, then as far as number 2 is concerned, I did this using compound angles. Did anybody do it in a different way? Anybody do number 2 differently? All right, so it would have been important when we are working with compound angles. Again, you do not have to write the part that says equal sign 60 plus 18, but you do have to write where we expand it, that you would get a mark for. Okay, and then we're going to use special angles and our ratio in terms of a letter. Okay, so the sine of 60 is root 3 over 2. The cos of 18 is root 1 minus t squared. The cos of 60 is a half. And the sine of 18 is t. Okay, you don't actually have to, you can, but you don't have to simplify it any more than that. You would get full marks at that stage. Okay, so important that you showed the expansion of the compound angle. The answer over here, there would have been a mark for Pythagoras, your diagram, and your answer in the first one. Are we all good with questions 1 and 2? Any questions when it comes to questions 1 and 2? All good. Okay, lovely. Then question 3 really wasn't too bad. Hopefully we spotted that that was a double angle. Okay, so the sine of 36 is 2 sine 18 cos 18. So we would have written that as 2t root 1 minus t squared. Again, must show the expansion in terms of t. And the last one, number 4. Okay, question number 4. So the tan of 198. Anybody want to tell me what they did here? Sorry, because all you hear is my voice. Let's see if we can hear your voices. Anybody tell me what they did for the tan? Yes, who's that? Oh, hi, Capano. I want to hear your voice. Lovely. Go for it. What did you do?
So what I did was, I was like 10 of 198 is 10 of 180 plus 18, and then I used the cost diagram. So 180 plus is still in the 10 quadrant, so 10 is still positive. So it's 10 of 18. 10 is y over x. So I used the Pythagoras diagram that we did, and I got 10 of 18 as t over root 1 minus t squared.
Beautiful. Oh, that's lovely. Well done. 100%. Perfect, 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 Capano. Okay, brilliant. Well done. Okay, so reducing and then the answer over there. Cool. All right. So hopefully you guys got all of that correct. Remember, it's either going to be double angle, it's going to be normal reduction formulae, 180 minus 180 plus 360 minus, be careful of signs. Or else it could be a compound angle, or it could be a double angle. The other thing that they could also sneak in here is your co-ratios. Okay, so don't forget about 90 plus and 90 minus. Okay, sometimes those come into play in these as well. Okay, another thing, not that we needed it for this particular question, we didn't, but when I'm talking about co-ratios is this idea. So the sine of 18 can be written as the cos of 90 minus 18. Well, it's okay, which would be the cos of 72. Okay, so don't forget about things like that as well. That's really important when you are working with trig. Okay, so we can write sine and cos. We can write anything in terms of sine and cos as the other one if we use 90 plus or 90 minus. Okay. All right. Now when it comes to question number 5, anybody have any brilliant ideas when it came to question number 5? If this was a question, yes, Nhlanhla, go for it. What would you do here? You're welcome to unmute and speak, Nhlanhla.
Afternoon, ma'am.
Afternoon.
Okay, ma'am. So what I did, since they said cos x plus sine x is equal to negative, it's equal to the root of 3 over 2.
Mm-hmm.
I wrote 2 sine x cos x.
So you wrote
the double angle for sine. So yes.
okay, so you wrote that.
Yes, ma'am. And I made the value for sine x the roots of 3/2 minus cos x.
Oh, okay. So in other words, what you did is that you then took, say, cos x, for example, you transposed it and you took it over to the other side. Is that right?
Yes, ma'am.
Is that what you're saying? Okay. All right. Now, I'm going to stop you there. All right. Because unfortunately, I love your ideas, but unfortunately, you are on the wrong track. Okay. But that's great. I'm glad you tried. Anybody try anything different? Linda, what did you do?
Ma'am, I didn't really try it, but I've got an idea in mind.
Uh-huh.
Ma'am, what if you squared both sides to make the root a fraction?
Brilliant. I love it, Linda. I'm so glad you had the courage to put up your hand and that you were thinking about it. That's really brilliant. Absolutely. Square both sides. So cos x plus sin x. Now, Linda, I don't want you to go anywhere. All right. We're going to do what
Yes, ma'am.
you said. I'm going to square the left-hand side. And I'm going to square the right-hand side. Okay, so now when I square the left-hand side, what do I end up with on the left-hand side? Can you tell me, Linda?
Ma'am, you end up with cos squared x plus sine squared x.
Okay, what do you forget? Careful, okay.
Ma'am, sorry.
Okay, it's all right.
Yes,
What do you
ma'am.
end up with?
Ma'am, it's cos squared x
Uh-huh.
plus I think it's cos x sine x. Was it 2 cos x sine x
There we
plus
go.
sine squared x?
Good. Now you thinking. That's beautiful. And then on the right-hand side, we're going to end up with just 3/2,
3
aren't
over
we?
2.
Excellent. Okay, so you've squared your binomial beautifully. All right, so remember there's always going to be a middle term. Okay, so now start thinking identities. Identities and double angles. What can you see going on the left-hand side?
Ma'am, could I get help?
Sure. Okay. What is
Uh,
sine squared? Yeah, okay, okay. Blah, blah, blah. Okay. Who was that? Was it you and Nhlanhla?
yes, ma'am.
Go for it.
So,
Help her.
ma'am, we can if we add cos squared x and sine squared x, that's 1, ma'am.
Beautiful.
And
Okay,
we
so
can move the one to the other side.
we certainly can. So I'm going to write the 1 plus 2, and I'm just going to change the, and you want us to transpose the 1.
Yes, ma'am.
All right. Okay.
Mhm.
Anybody else?
Okay, so that's a half, ma'am. 3/2 minus 1 is a half.
Is a half.
So therefore, okay, 2 sine x cos x is 2 is sine 2x, ma'am.
It is. There you
So I
go.
think that's the answer, ma'am.
That is. It is. Well done. Well done. Good stuff, guys. Well done. That's brilliant. Okay, so I think there are a few people in the chat that were Nolwazi, Mamelo, lovely, well done. Okay, really nice to hear your voices. Thank you so much for doing that. Okay, good job, everybody. Yes, and Nhlanhla, you and Linda did that together beautifully. Okay, good job. Okay, so that was just a little bit of problem solving thrown in. Let's go down and go and have a look at what else is here. Okay, so if you'd like to try some more of these sorts of questions, you're welcome to take a screenshot of this one. So the sine of 12 is equal to k. It's a very similar idea to what it is that we've been doing earlier in the lesson, the questions that we have already worked through. If it's okay with you guys, what I'd like to do is just go and have a look at the slightly more difficult questions. That's fine, Aaron. Okay, or you can take screenshots. Actually, maybe I should rather ask you than deciding what it is that you need. Do you guys, are you happy to try questions that are a little bit more difficult? Do you feel okay? I feel as though we've got the basics here. Yes, yes, please. All right, cool. I'm glad you feel like that. We could try, absolutely. So there's two questions here. Let's call this one number 1. And let's call that one number 2. Is it too simple, Aaron? Okay, all right, I can make it more difficult. That's not a problem. I'm just going to go and fetch this. Okay, there we go. So let's have a look at these. So if the sine of 9 is equal to k, determine the value of the sine of 18 in terms of k. Do you guys want to try that by yourselves? Yes, okay. All right, that's fine. Yes, you want to try it on your own? Not a problem. I'll be quiet for a little bit. That's fine. Do number 2. Try number 2. I've also got another question. I don't know if we'll have time to do that as well. Maybe I'll just go and I'll move it up here. Let's make that question number 3. Yeah. There we go. Okay. When you, Mamelo and Linda, when you say you're done, are you done with number 1 and number 2? Are you done with number 1, 2, and 3? And you're done with number 3 as well. Okay, that's good. Mamelo, you done with 1, 2, and 3? All right. So you guys say that you're finished with 1, 2, and 3. Okay, we don't have an awful lot of time left. So let's go through some answers. All right, so now I want answers from you guys. Okay. All right. So number 1. What did we get? If sine 9 was equal to, okay, what did you get for the sine of 18?
Ma'am?
Yes, Linda?
Ma'am, what I said is that sine 18 is a double angle.
Mm-hmm.
So
So
I
you said
got
sine 18 was equal to?
2 sine 9 cos 9,
Mm-hmm.
which is 2k times root 1 minus k squared.
Okay, excellent. And then you showed where you got the root 1 minus k squared from. Yes?
Yes, ma'am.
Okay,
Yes.
good. All right, that's fine. Good job, Linda. I like it. That's fine. Not a problem. Okay, number 2. Who wants to do number? Sisipo? You got your hand up, Sisipo. You want to do number 2 for us? You're welcome to speak, Sisipo. There we go. So 60 minus 55. Good. Minus 55. Good. Okay, Sisipo.
Ma'am, sorry, I just want to ask a question. When you doing these type of questions and you have to do Pythagoras to find one of your other sides, do you have to
Yes.
show that you did Pythagoras?
Yes, you are supposed to do that.
Oh, okay. So
Okay.
is it just, do you have to show it, or do you get marks for it?
You get marks for it to see, Paul.
Oh,
So
okay,
yes, you
thank you.
must show it. Okay, you must show it. Okay. All right. What should we write next? Yes, I see there's an echo. Compound angles, absolutely, Mamelo. So we've got a cos compound angle here. So we're going to write cos 60, cos 55 plus sine 60, sine 55. That's it, Nolwazi. Well done. Good job. Okay, so cos 60 is root 3 over 2. The cos of 55 is p. The sine of 60 is, sorry, I'm talking nonsense. The cos of 60 is a half. Sorry. The cos of 60 is a half. Cos 55 is p, sine 60 is root 3 over 2, and the sine of 55 in this case would be root 1 minus p squared. That's it. Okay, and again, what I should have done, I've been naughty in both of these cases. I should show where I'm getting that from. I should show my diagram. I should label my angle, and I should have there p squared plus y squared equals 1 squared, and I should show that y equals root 1 minus p squared. Okay, and I should have shown the same thing over here. Okay, the next class is going to begin shortly. Can anybody tell me what they got for number 3? How did we do number 3?